Mastering AWS Networking, a complete guide to building secure and scalable cloud architectures. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction: Refreshing basic networking fundamentals. In today's cloud-centric world, a solid understanding of networking is crucial for leveraging AWS's full potential. Networking is the backbone that connects all components in your cloud infrastructure, making it vital for performance, security, and scalability. This podcast will dive deep into essential AWS networking concepts, helping you master the intricacies of network design and management on AWS. Network addressing and routing. The evolution from classful networking to CIDR before the classless interdomain routing. CIDR, advent, the Internet relied on classful networking, which grouped IP addresses into fixed classes, A, B, C. However, this rigid structure led to inefficient IP address utilization. CIDR revolutionized network addressing by allowing more flexible and efficient allocation of IP addresses. Routers, directing traffic on the Internet. Routers are critical in networking. They act as traffic directors, ensuring data packets reach their intended destinations. They use routing tables to determine the best path for data, playing a vital role in both traditional networks and AWS VPCs. CIDR and subnetting, optimizing network allocation and routing. The role of CIDR in efficient address utilization. CIDR allows for allocating IP addresses based on the number of devices in a network rather than adhering to fixed classes. This flexibility reduces IP address wastage and enables the creation of subnets that precisely fit your network's needs. Subnetting, enhancing network efficiency. Subnetting divides an extensive network into smaller, manageable segments, improving security and performance. By isolating different parts of your network, you can control traffic more effectively and reduce the potential impact of network congestion or security breaches. Calculating network prefixes and host counts. Calculating network prefixes and host counts is crucial for efficient subnetting. The network prefix indicates the portion of the IP address that identifies the network, while the remaining bits determine the host addresses within the subnet. IP addressing: public, private, and reserved. Understanding public versus private IP addresses. Public IP addresses are globally unique and accessible over the Internet, while private IP addresses are used within private networks and are not routable on the public Internet. AWS provides both types, allowing you to manage external and internal network communications effectively. Address allocation for private internets. In AWS, private IP addresses are used within VPCs to facilitate communication between resources without exposing them to the public Internet. This setup enhances security and allows for better control over network traffic. Reserved IP addresses and subnets. Reserved IP addresses in AWS subnets are critical for network stability and management. AWS automatically reserves the first 4 IP addresses and the last IP address in each subnet for network management purposes, ensuring proper subnet functionality. Virtual Private Cloud, VPC, your private cloud on AWS, defining and controlling your virtual network. A virtual private cloud, VPC, allows you to create a logically isolated section of the AWS cloud to define your network architecture, including IP address ranges, subnets, route tables, and gateways. IP addressing in VPCs, IPv4 and IPv6. AWS VPCs support both IPv4 and IPv6 addressing, giving you the flexibility to manage network traffic efficiently. While IPv4 addresses are more common, IPv6 is increasingly important due to its vast address space and future-proofing capabilities. Public and private subnets, access control and routing. In a VPC, public subnets are accessible from the Internet, while private subnets are isolated from direct Internet access. This segmentation is crucial for securing sensitive resources while allowing necessary communication through managed gateways and routing. Routing and security, managing traffic flow and access. Route tables, directing traffic within your VPC. Route tables in AWS VPCs direct traffic between subnets and to and from external networks. By configuring route tables, you can control traffic flow within your VPC, and ensure data reaches its destination securely and efficiently. Network ACLs, NACLs, controlling subnet traffic. Network Access Control Lists, NACLs, are stateless, Layer 4 firewalls that control inbound and outbound traffic at the subnet level. They provide an additional layer of security by allowing or denying traffic based on rules you define. Security groups, protecting your EC2 instances. Security groups are stateful firewalls that control traffic at the instance level. Unlike NACLs, security groups automatically allow return traffic, simplifying network security management for your EC2 instances. Advanced AWS networking services, extending and enhancing your network. AWS Transit Gateway, simplifying network connectivity. AWS Transit Gateway is a central hub for connecting VPCs and on-premises networks, simplifying network management and reducing the complexity of maintaining multiple peering connections. AWS Outposts, extending AWS to your premises. AWS Outposts bring AWS services to your on-premises environment, providing a seamless hybrid cloud experience. This service is ideal for workloads that require low-latency access to on-premises systems or need to meet specific data residency requirements. AWS Direct Connect, dedicated connections to AWS. AWS Direct Connect provides a dedicated network connection between your on-premises data center and AWS, offering consistent, low-latency performance for transferring large amounts of data. Internet Gateways and NAT, connecting to the Internet securely. Internet Gateways, enabling Internet communication. An Internet Gateway, IGW, is a VPC component that allows communication between instances in your VPC and the Internet. It enables outbound and inbound traffic to and from your public subnets. Network Address Translation, NAT, protecting private subnets. NAT allows instances in a private subnet to connect to the Internet while preventing inbound connections from external sources. This is essential for scenarios where instances need to download updates or communicate with external services securely. NAT instances and gateways, different approaches. AWS offers two NAT options, NAT instances and NAT gateways. While NAT instances provide a more customizable solution, NAT gateways offer a managed, highly available service with automatic scaling and redundancy. Elastic IPs and Bastion hosts, managing public IPs and secure access. Elastic IP addresses, static public IPs for dynamic environments. Elastic IP addresses in AWS are static public IPs that can be reassigned between instances, providing flexibility and continuity when managing public-facing applications. Bastion hosts, securely accessing private instances. Bastion hosts act as secure entry points to instances and private subnets. Limiting SSH access to a single, hardened Bastion host can enhance security while allowing necessary administrative access. Virtual Private Networks, VPNs, secure remote access. VPNs allow secure connections between your on-premises network and AWS environment or between different VPCs. AWS offers managed VPN services that simplify the setup and management of secure, encrypted connections. Conclusion. Understanding AWS networking is essential for building secure, scalable, and efficient cloud architectures. From primary IP addressing to advanced services like AWS Transit Gateway and Direct Connect, mastering these concepts will empower you to optimize your network infrastructure on AWS. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.